In this episode of the Devlab series, we will deploy a Gitlab container in the Devlab BVE that we created in the previous episode. Then we will commit our code and publish it to our new Gitlab server. This would be our first step on the way to enable running our Ansible playbooks in Gitlab pipelines that we will do later in this series. First, for the people following the series from the start, I would like to mention some updates that I made to the network setup. Previously, I was running a BVE that simulates my main BVE because I wanted to test things in a new setup. The simulating BVE was connected to the same bridges on the main BVE, which made it work as if it was the same BVE, with one exception. It was a nested virtual machine, which had its performance impact. When I created another BVE nested inside it, the performance was catastrophically degraded because of the depth of the virtualization nesting, which forced me to move the Devlab BVE to the main BVE. The simulating BVE is still available in case we need to test something on the main BVE. While doing this change, I adjusted the resources, and I think now I have a good Devlab BVE that we can use in this series. I recreated the router on the main BVE using the same Ansible playbook and created two dev machines on the new Devlab. One uses Debian and the other uses Fedora. I tried installing Gitlab in a Debian container, but the install failed. I ended up with a working Gitlab instance, but a failed install is not good enough for me. During my attempts, I used a guide from Ronald Ferrer that he published on Medium 3 years ago. The guide was for a different setup, but I could not replicate his results in Proxmox VE with the latest version of Gitlab. I tried a few other systems and got the install to work perfectly in Alma Linux 9. However, the Alma Linux 9 container in Proxmox does not include the OpenSSH server package. We have seen this problem earlier with the Fedora container in episode 2. So now I have to solve this problem in a generic way so that we can use the same Ansible role for Fedora and Alma Linux containers and other containers that require installing OpenSSH server. Here is the role that I created to solve the problem of missing OpenSSH server package. This role contains only one task, and it is designed to run on the BVE host, not on the machine, because we need to use the BVE tools like the command pct-exec that comes with BVE to access the containers that do not have SSH server. So first we run pct-exec on the container, and then we pass the command in a loop. The loop contains two commands. First, we install the OpenSSH server, the missing package. Then we enable that package and we start the service immediately. And here is the Gitlab role that we use to install Gitlab inside the Alma Linux container after we enable SSH. First, I'd like to mention this hack. This hack is a hack I got from this article that I mentioned earlier, and this was designed for Debian. I frankly did not test removing the hack and installing Gitlab on Alma Linux. Maybe we should test that, but the install takes about 6 minutes. So I'll test that and remove it if it is not required later. Then we install some missing packages, or we make sure that they are installed. So these are normally installed. Perl and postfix are not installed, so we install them. We enable the services. SSHD should be already enabled. And then we enable postfix. This is the script that installs Gitlab, the Gitlab install script. And it depends on the edition. So if you want to install Gitlab Community Edition, you specify in the variable that has GitLab-CE here. If you want to install the enterprise version, you can specify GitLab-EE. in the GitLab edition variable. So what we do is we download the script, and we make it executable, and then we execute the script. This script will set up a repository that includes the GitLab edition that we have. So next, we can install GitLab using this repository. So we install the GitLab edition that we specified. Here we have to pass a few environment variables for the setup. First, we want to pass the external URL that we want to access GitLab on. Then we pass the GitLab user password, which is not required, but I think passing the GitLab password here is easier than collecting the default password that GitLab will assign during install and reading it from the container. Then, since we are not available to the public, we are not in a public network, we cannot use Let's Encrypt. So let's save some time by disabling Let's Encrypt. Now I put this in a playbook. This is the GitLab playbook. First, we build the container using our two roles that we have used multiple times earlier. Then we have the enable SSH role that runs on the Devlab BVE. Those run on localhost on the Ansible controller, but this one has to run on the Devlab BVE. Then we set up GitLab, which includes running the role that we were exploring on the GitLab host that we created in the first task. Then we have a role to configure GitLab, and I'll show you this role. This is the role that I created to configure GitLab. It uses the community.general collection models that are specific for managing GitLab. For example, the GitLab group model, the GitLab user model, the GitLab project model. So what we do is we create a group or a few groups as we specify in the variables file. We create a user, a Devlab user, and then we create some projects just to test these models. This role is just for testing, and your setup might vary, so you need to change these roles according to your needs. And you can also change the variable file that passes the values to these roles. So we look at the GitLab variables files. We start with the VM ID on 100, and I want to use GitLab CE as an edition. I tested the same setup on GitLab EE and it worked exactly the same. But I'm not sure what the differences are. I prefer to use GitLab CE, the community edition of GitLab. You need to have the Alma Linux template installed in Proxmox, and we have seen how to do that with the previous templates. We installed the Debian and Fedora template, the same way we installed the Alma Linux template. We need to be a little bit generous with the resources for GitLab because GitLab is like resource extensive. The container needs to be privileged. I have not tested installing GitLab in Alma Linux in an unprivileged container. This was part of my setup for the Debian container. I will test it with unprivileged container, and if it works, I will remove this line. Then we have the GitLab URL, and since we don't have DNS yet, I'm using the IB to access GitLab. Later on, we will reconfigure GitLab to use the DNS when we have a DNS server in our network. The edition is GitLab CE, and I'm creating two groups, one called internal with a visibility internal, and one is external with the visibility public. And I'm creating three projects. For example, a Devlab series automation project, which will be the repository that we will push our code to. This would be in the external group, and it would be a public repository. Then I'm creating a snippets repository that is also public in the same external group. And then for testing, I'm creating a repository called private code. I'm putting it in the internal group, which is internal, and the repository is private. On the right side of the screen, we see a virtual machine that is running Fedora and the KDE Plasma desktop. This VM would simulate my development machine inside the Devlab. This machine is only connected to the VMBR100 on the main PVE. So it acts as if it is inside the Devlab. However, I put it in the outside in the main lab to avoid nesting the virtualization. From this dev machine, we can access our Devlab BVE. And we see that we have a Gitlab instance with VMID 100. We need to remove this instance when we run our playbook, so we pass the variable recreate equal true to the playbook. I shut down the instance before running it because normally when I tested this playbook, it sometimes it failed because that GitLab container takes a long time to shut down. So now we created the GitLab container with the GitLab CE name, and we have installed SSH, and we are now logged into the container. The install will take more than 6 minutes, so I will come back to you when the install finishes. They're all finished successfully. I don't see any errors in the logs. So now let's try to log into the Devlab, to the GitLab container. For that, we need the password, and the password is in the vault. It is in the vault template, and you see GitLab requires complex passwords. So I put some complex passwords here. These are the real password. They are not hashed. We log in with root and the root password, and we see what we get. And we get a nice administration area with 3 projects. One is in the external projects, two are in the external projects, and one is in the internal projects. Two are public and one is private, which is what we expected. If we look at the administration area, we see we have 2 users, 3 projects, and 2 groups, which is what we expect. So now let's connect GitLab to our VS Codium. For that, we need to install the GitLab workflows extension. GitLab workflows, I think this one, yes. So we install the GitLab workflows extension. And once the extension is installed, we can hit F1. And now we have GitLab add account. I can type GitLab add account, and I see that I have this command. I want to add an account to GitLab. We want to use the, first it asked me for the URL, and I can copy the URL from here. Then it needs a personal access token. So if I want to connect with root, for example, I need to create a personal access token from here, from edit profile and account personal access tokens here. Yes. So let's create a new personal access token. We call it Podium Devlab. Or better, this would be Ansible. This will be in the Ansible controller. Ansible controller Devlab, and we give it access to everything. Of course, if you want to give it access to everything, you can do. So now I can copy the personal access token and put it here. And added the personal access token to your account. So if I look at the GitLab here, I don't have a Git repository connected. So let's start by initializing a Git repository. So this is a Git init here. Clear the terminal. Git init initialized an empty repository. So let's check our repository. Devlab series automation. This is our repository that we want to use. So we need to connect the remote. Copy the initial branch, default branch is main here by default on my hub. So git remote add origin. So we added the origin now, and now we have some things that we can commit and manually assign. It is here is automation. So now we have the repository connected. I can manage the connection between my code and GitLab from here. So let's look at the code and commit it. I'm committing everything in roles. I'm committing my variables. Yes, but you need to change them according to your needs if you want to use them. I'm committing the Vault template and I'm ignoring everything else in the Vaults directory. As we have seen in git ignore. This configuration file sets my vault password. You need to create this password. You need to create this file if you are going to encrypt your vaults. My vaults are encrypted now. You put the password inside this file in your home directory. Those are the playbooks, the inventory. Yes, why not? Like your inventory needs to be different. Like each person has their own inventory. And the license, I'm publishing this code under the MIT license, which is allows you basically to do anything you want with the code, but not to hold me responsible for anything. I'm not liable for anything you do with this code. Then we have playbooks and we are ready. Like you might notice that I changed a few things in the code from the previous episodes because I wanted to run Ansible lint. Ansible lint in this. Let's see if we still have everything correct. Yes, 0 failures, 0 warnings, 97 files. So I fixed all the errors in Ansible lint, and now I can call this initial commit or initial commit, and I give it 00 season 1 episode 06. We are in the 6th episode of the series now. Or let me add these first to the staged and commit. So now we have committed. Let me tag the code, this commit, git tag season 01 episode 06 and git push. We need to set the upstream. That's right. I'm sorry, git. So now we have pushed our code, and let's push the tag. And we pushed the tag. So if we look at our repository here, we see our code, the code works, and we see our tag. Now the next step is to push this to GitHub. I want to push it either to GitHub or to gitlab.com, and I'm still not decided on what to do. So I will add the code, the URL in the article, and the article link will be below this video. The next episode, we will build the GitLab runners, and we will build that using Ansible so that we can start using GitLab continuous integration features inside our Devlab. The first thing we will do with continuous integration is that we will configure our router so that if we add a variable into our variables files for the router, the pipeline would deploy that directly to the router. Then we will install Jenkins using Ansible as well, and we will have another option for running pipelines using Ansible. We will also create shared folders across all the dev containers so that you can move data between all the dev containers if you need to. We will create a Node.js development container and more development containers later with PHP and with Python and with for JavaScript also. So more to come in the Devlab series. Please subscribe and follow the series if you are interested.